In this video, much like the one I did on combinations, my goal here is to just work through a few examples, one simple and one more difficult, and just kind of explain a little bit on how to solve the types of problems that you're going to see in this course. Alright, so a permutation is a collection of objects where the order in which they are chosen matters. Case in point, selecting the top N in a race, the arrangement of letters in a word. Obviously in dog, if you switch the D and the G, you have something totally different. You have God. So it does matter what order that we put letters in a word. Alright, so this is our formula. Just to kind of reiterate, if you watch the combinations video, then you know what this is, but I'm just going to assume that you probably haven't. Who can tell? This is a factorial, and the way that the factorial works, don't think of it as like the numbers yelling at you. 5 factorial is 5 times 4 times 3 times 2 times 1. And really, honestly, like we don't need to worry about the 1 because it doesn't change anything. But 5 factorial is 120 because 5 times 4 times 3 times 2 is 120. So that's all factorial means. I'm just multiplying all of the descending integers. All right. So here's an example of a permutations problem. 10 runners compete in the 100-meter dash. If the first through fifth are awarded prizes, how many ways can I award the prizes? All right. So suppose I have 10 runners. And I'm just going to go ahead and assign first through fifth. I'm just going to choose them at random. We'll say first, second, third, fourth, and fifth outside lane. Alright, is that different from first, second, third, fourth, fifth? Well, yeah, the first and the second place change, so that's a big deal. Alright, so the order does matter here, so I know I'm doing a permutation. I see that there are 10 things I'm choosing from, right? Here n is equal to 10. And what I'm doing here is I'm making, right, if I look at this for each of these, oops, missed that one, I'm making 5 selections. So now I just go ahead and plug in 10 and 5 everywhere where I saw the 10 and 5 in the formula. So what I'd have here is 10 factorial divided by 10 minus, and I go ahead and put the 5 in there. Alright, so now I just go ahead and solve it. So the way I'm going to do this is I'm going to write this thing out the long way. Yep, takes a little bit of time, but the hardest part of these problems really is writing it. So 10 minus 5 is 5, so I do 5 factorial. You do not do 10 factorial minus 5 factorial. You do not distribute the factorial. That's not a thing you do. So you do 5 factorial, which is really just 5 times 4 times 3 times 2 times 1. The ones cancel themselves naturally. They don't really do anything, so that's fine. And 2's cancel. 3's, 4's, and 5's. So now I just do 10 times 9 times 8 times 7 times 6, and that comes out to 3360. So the answer to my question here is 3360. There are 3,360 ways I can give out those medals. That's a big deal. Alright, let's move on. This one's a little bit harder. I mean, in case you were wondering, I said it was harder. So here's what we got. 2 heats. Alright, so let's think of like 2 totally separate races, because that's what a heat is. And there's heat 1. That was a crazy T. That's not even normally how I do my T's at all. And heat 2. Alright, there's 6 swimmers in the first heat and 7 in the second. 2, 3, 4, 5, 6, 7. And 6 in this one. And what it says I'm doing here is I'm choosing the top 4 from each of them. Now, the lane assignments, here we see the lane assignments depend on their position. So it's obviously better to come in first in your heat than it is fourth. So let's say 1, 2, 3, 4. It's better to be this guy than it is this guy. So it looks like I'm choosing 4 from here, and I'm still going to be choosing 4 from here. Obviously, from the first heat, I'm choosing from 6 of them, and I'm not using the notation here because I don't actually know what I'm looking at yet. But in this second heat, I'm using 7. Now, the really important part of this question is how it said the lane assignments depend on their position. That tells me that it doesn't just matter arbitrarily if I'm first or fourth. It actually helps to be first. So these are actually permutations. Alright, so basically I have 2 separate problems here. And what I'm going to do at the end is multiply these together, because this is the number of ways the first event can happen. This is the number of ways the second event can happen. So if I want to find the number of ways both of them can, because I said how many ways can the lanes be assigned, that's the number of ways both of them can happen multiplied. Alright, so what I'm going to go ahead and do here is I'll do this one first, and then I'll do this one, and then we'll just multiply them together. Okay? And yes, I do need more space. Thank you, me. Alright, so first thing I had here was 6p4. So, I use my formula. And I get 6, 5, 4, 3, 2. I'm not going to write the ones anymore because that's irrelevant. 6 minus 4 is 2. 2. So these 2's cancel. And 6 times 5 times 4 times 3 comes out to be 360. And then I do the same thing here, which is really going to look exactly the same. I'm just going to be doing 7 minus 4. And, well, I'm sorry. Yeah, 7 minus 4. So what I end up here is 7, 6, 5, 4, 3, 2. Not going to worry about writing the 1 again. 7 minus 4 is 3. 2's cancel. 3's cancel. Alright, and what I end up with here is 840. So now what I do is I take these 2 numbers, I multiply these together, and I get something huge. I don't think the officials of this meet knew that there were going to be 302,400 ways to assign those final lanes. Alright, but I basically just did 2 permutations, multiplied them together. Alright, the tricky part of some of the basic problems is figuring out whether you're going to use combinations or permutations. The formula can get complicated, but it's really straightforward when you take your time in these calculations. Alright, I hope this helps. Good luck.